Here I have a model of a building, and it has these braces that can dissipate energy, similar to a real building designed for earthquakes. So let's see how long it takes for it to fall down. You can see the braces are moving here. They're dissipating energy. And now it starts to lean in one direction. And then that's when it breaks. So, I'll put this building back together here. Okay, so that's what that looks like. Now let's see what happens if we take these bottom pieces out. And now it's effectively a pinned base. So before I remove those pieces at the bottom of the bottom of the building was essentially a fixed condition. You had these connectors that were going between the two columns that prevented the column bases from rotating. Now, in removing them, I'm allowing the column bases to rotate, like this pinned condition here. The column is allowed to rotate freely about a point at the bottom. Now, if I do statics on this, which is a way to analyze forces on buildings and how much they deflect, I'm able to come up with equations for how much the building will deflect for the same amount of force. And so it's delta 1 for the fixed condition and delta 2 for the pinned condition. If the force is the same, if the height of the column L is the same, if the elastic modulus and area moment of inertia are the same, which those are properties of the columns themselves. Not really important for this. Just as a side note, elastic modulus has to do with the material property of how stiff the material is, and the area moment of inertia has to do with, okay, for that column section, how stiff is and how strong is the column section. So you can look at these, calculate them. This is for a rectangle section and for a linear material. But that's not needed for the sake of determining the difference between fixed and pinned. So with the fixed condition, you can see that there's a 24 in the denominator. And then for the pinned, there's a 6. So since everything else is the same, the deflection for the pinned condition will be 4 times that of the deflection for the fixed condition. So in removing those pieces, the building is going to be a lot softer, not as stiff on the first floor, and that is going to be the point of failure for the building. Let's see how quickly it collapses in the case where it's pinned. Almost immediately. And that's a soft story mechanism right there.